is chapter 8, and in that chapter, we learn about the network layer. So remember what we did. We started with the physical layer. Then we went to the data link. Then today we're going to do a network layer, where we talk about packet or logical address. And here is copy, paste. So here we're going to deal with the router. We're going to deal with the router. So what can we find at the network layer? It's what we're going to do. So network layer, characteristics. Okay, so you know where it is. As you know, anytime you have questions, please unmute yourself and ask the questions. The OSI model layer 3 is this one is a network layer. So your data comes from. So when you want to send an email, for example, and press send, layer 7, layer 6, layer 5 is called the data. When it reaches layer 4, it's going to add extra info, like an envelope. You're going to put your data in an envelope. Now we call it the segment. When the segment reaches layer 3 will add extra info in other envelope before sending to layer 2. So it's going to add IP addresses or a cell phone number to your packet. So at the network layer, we have IPv4, like how we're going to assign cell phone numbers or IDs to people. We have IPv4 and IPv6. We'll check later the difference between these two. So at this layer, we're going to add extra info like IP addresses. Encapsulation, it means when we receive a segment, we'll put it in an envelope, we encapsulate it, and we add extra info. Routing, it's where the router will read the packet, it will check the IP address and send to a destination. So encapsulation is what? If I receive, for example, your parcel is ready at your home place, you call DHL to come collect, they'll collect it and will put, so this is your parcel. DHL will come, put it, and this we're going to put your parcel in the DHL packaging. So we say we are encapsulating, we're adding extra info. So at the layer 4, the segment, when it reaches layer 3, you're going to add IP addresses, extra info. Okay, so some characteristic of IP. When you send something, it's connectionless. IP does not establish a connection with the destination before sending the packet. That's the definition of connectionless. You just send, for example, if I want to call you, your cell phone will ring. If you don't pick up, no communication. It means our cell phones are connection oriented. We need a connection before we start communicating. IPv4, or it's connectionless. It's like the post office. You drop your envelope at the post office and done. Is it going to reach the destination or not? We don't know. So IP is connectionless. There is no control information needed. The destination will receive a packet when it arrives, but no pre-notification are sent back to IP. So we have other characteristics that for now you can read, but I'll give you what is extremely, let's say, more important. So we have IPv4 and IPv6. So later on, we'll download Wireshark and install it. To grab some traffic, we're going to open and we see all this stuff inside. We'll see, for example, source IP and destination IP. So for IPv4, we have so the version will be version 4 source IP. Maybe my laptop, I want to send someone to someone else, it will be the destination. These are a bit of a theory. So if you want to really understand this picture, in EtherCAD, you go to this slide and you will explain each section. For now, for us, what we need, I'll show you exactly. You can check this video. We do some demo. We explain more stuff. It's quite interesting. Now we have IPv6. This one is longer than IPv4. Why we are having IPv6? It's like iPhone. We have iPhone 10, iPhone 12, iPhone 15. So we add more features. So IPv4 is almost finished. So we need extra IPs. Then we created something a bit longer called IPv6. So IPv4 has 3 major limitations. It's almost finished and has less features. It's like the new cars we are having now. Now we're making electric cars. So when things evolve, they add more features, more new. We'll have time to do one by to check also IPv6. We have a chapter for that. If you grab a IPv6 packet, you will also check the version here. It will be version 6. Source IP, destination IP is still there, and we have less field. Here it's much simple. It's much clearer than the IPv4. IPv4 it's full of info, you see. But when you go to IPv6, it's a bit simple. If you want to understand each of these fields, it also, so you can have a look here and then continue. Okay, we continue. You also have a video. We'll use this software called Wireshark. It's like traffic cops. They hide on the highway. They check the traffic. They can stop any car and check. It's the same thing. We listen to a network. We grab some traffic, grab some packets, and we check what is inside. So we'll do a demo for that also. We'll also have time to install Wireshark and check also. Okay, then we now come to what is called a router. The default gateway I think I did explain to you. So for here, I prefer doing a demo so that you can understand properly. So any questions? First, let me check. Any questions?
Hello, sir.
Yes.
Yes, I would like to ask, why do we have IP4 and 6 and we don't have 5?
I'm sorry, you say?
I said, why do we have the IP4 and 6, IP4 and IP6, but we don't have the IP5?
Yes, it's the way themselves we decided to make things.
Oh,
Okay, so it's like we have iPhone 15, and suddenly we decide to jump to iPhone 20. Yeah, these people managing this stuff. We decided to jump. It's a good question.
okay, sir. Thank you, sir.
Yeah, I like questions. Don't think about it's a silly question or what. No, ask. It will help all of us. Thank you, Mr. Light, for your question. Any other questions? Okay. So at this layer, the big boss will be what? A router. So the router, it's a device in the network. This is an example of a router. So in your company, you have a lot of PCs and laptops. We are all linked to a switch, and the switch is connected to a router, and the router is connected to your ISP, Internet Service Provider, to go to the internet. So it's the router who will forward. So the router is like a security guard, security agent at a university. You come and you say, sir, I want to go to engineering building. The security guy will check on his table. I know it. It's on my list. Engineering building, go to that way. Someone else comes. So you send your data. It will reach the router. It will check where to forward your data. So it will check. Okay, sir, I want to go to medical science building. It will check on the list. Say, I know it. Go that side. Someone will come. Sir, I want to do tourism. We say, it's not on my list. I don't know where to help. I don't know how to help you, where to send your data. So the router has a list of known routes or known networks. That list is called a routing table. You see, routing table, a list. For example, education department, go to, I don't know, go to a blue building. Engineering, if you want to go to engineering, go to yellow building. So the routing table is inside the router, is the list of all the networks the router knows to be able to send your data to help you, to direct you. You see. So I prefer doing a demo so that, so inside the routing table, we have 3 types for now. We have routes that are directly connected. So if you take R1, the network in yellow, we are directly connected to the router. So automatically, they are listed in the routing table. Remote network, if something is far, is not connected to me, router 1, it's a remote network. How will I know about that remote network? Because if I don't know that remote network and someone want to communicate with these guys, I won't be able to help them because I don't know where to guide them. So we need to add that remote network in the routing table. We can add manually with a static route, something we'll do a bit later, or it can be dynamically added via routing protocols. We will study also that a bit later, maybe next chapter or something like that. And we have something called default route. This forwards all traffic to a specific direction when there is no a match in the routing table. For example, you want to go to tourism building or department. I don't know, it's not on my list, me as a security agent. And I say, okay, you know what? I don't know where to help you. Go back to admin building. You see, it's a default route. If I don't know, I send you to admin building, and there ask them, they'll double check if really you're registered, you belong to this campus or what, and will guide you. So please check this one, it's extremely important. Okay, we continue. So remember, this course we are doing is called CCNA1, Introduction to Networks. We are preparing you for the next CCNA, CCNA 2, 3, and 4. So we're preparing, so anything here will go deeper in the next classes. Okay. Now, static routing, how to add a remote network manually in the routing table is called static routing. Remember, you can add manually a remote network, we call it static route, or dynamically using a routing protocol that we'll check later. So for now, how to add a remote network manually, it's with a static route. So check this and I'll explain to you. Okay, so how are we going to add manually? This is R1. This network far here, 10.1.1.0 is far. It's not directly connected to me. It's far. So I need to add that route in my routing table for anyone who want to communicate with them to be able to. So how I do in R1, in the global config mode, I type IP route, and this remote network 10.1.1.0, I add it 10.1.1.0. So I add the remote network, the subnet mask, then I add IP address of next hop router. So router 1 is here, next hop is router 2. I add this IP. address, dot 26, dot 226. So if you have a router and you want to add a remote, you type IP route, the remote network and subnet mask via this IP. We'll get time to do some examples. So check again and you continue. Okay. Now, when it comes to dynamic routing, it's another way to add remote network in R1 in a router. We need to configure to enable that dynamic routing protocol. You can have EIGRP, we can have OSPF. So at a later stage, as we see here, OSPF, we have the names of dynamic routing protocols that we enable, we activate on the router, on all routers. Then we're going to exchange knowledge. R2 will say, hey, R1, I know all these routes. Do you also know them? He's going to check his table, say, I know half of them, but not the other half. Let me add the other half in my routing table. You see? So now we're going to communicate, to talk to themselves and exchange, update the routing table automatically. You don't need to manually add. So check this also, and I'll continue. Okay, we continue. You have a video with some explanation. So for us, we'll do some labs. I will explain properly. So this is an example of a routing table. This is R1. If you want to view that table, you type show IP route. And you're going to list all the route the router knows. So when you have a route, it's going to specify how I know that route. If you see L, like here, it means that route is directly connected to myself, the router. Normally, the L is the IP address of the interface. It's directly connected to myself, but L is local, is my interface here, or my interface here. If you see C, that network has been added because it's directly connected to myself router 1. No, so this one, 10.0, and this one, both will be displayed in R1 because we are directly connected. See 10.0, C, 10.0 is here, is directly connected via that interface G000. So this network directly connected via this interface. This network also is directly connected, so it will be in the routing table. So how do I know that network? C, because it's directly connected to myself. If you see L is connected to myself, that it will IP address of my interface here. I know C, so we know L, we know C. If you see anything else, it means it's, if you see S is static root, it means myself, I manually added IP root and what. This network is S, has been manually added, static root. Anything else like O, D, R, it's dynamic routing table and dynamic routing protocols. If you activate them on the routers, we'll start exchanging the knowledge, the routes on the routing table. So have a look on here and here. So here you have a code, and if you see L, it means local. If you see C, it's connected. If you see S, what. So check if you have questions. Feel free to ask them. Okay. We'll get time to check again in. So most of what we're going to do in this CCNA is this one. It's this one. So that's all for this chapter, is just to prepare you for some stuff. So this is some. Okay, we'll check that later. So any questions before? So the chapters that we'll be doing now, they are very short. So I'll try, if it's very short, we can add a second one for us to clear quickly, for us to get more time. Sorry, more time to do revisions and to practice and all of this stuff. Any questions, guys? Okay, let me check ARP. It's something we can do a bit later. Let me check how many pages are there. Okay, ARP we can do a bit later. It's not a big deal. I want to do something that's related to what we did now. Basic router configuration. Let me check how many pages. Yeah, this one is very small. Basic router configuration, because we deal with layer 3 packet. We'll see this router, how it works. Basic router. So when you have a router, it's something called basic configuration. Basic router configuration. So it's a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. It's 6 and 6 settings we have to do. First thing first, we need to configure the device name. So in the global config mode, you tap host name and the name. So what we'll do on Saturday we'll have a kind of summary from chapter 1 to 10. I'll try Saturday to quickly do chapter 9. It's about ARP. It's very short and simple. Then we'll do revisions. It's open questions. If you didn't understand something, write it down. We're going to go through it. If you register late, you didn't understand something, put it down, write it down. When it's your turn to talk, you will let us know and we'll help you. Because from next week, we'll try to, last 2 weeks, we'll finish CCNA, then we have 1 week to prepare your exams. So Saturday, it's general revisions in chapter 9. Then if you have a bit of time, you can do one lab for basic router configurations. So when you say basic router configurations, step 1, configure the device name, host name, and a name. You must secure the privilege mode, enable secret and your password. The user mode, secure the user mode. Line console 0 and what we did. Secure the telnet and SSH. This one we can also do. We'll do a demo. You need to encrypt all plain password. We type service password encryption. Because we are doing configuration, we go to global config mode. And if you want to notify something, someone banner message every day. All the time, when we start a lab from now on, if you see basic switch configuration, basic router configuration, you need to do all these 6 steps. So have a look and we continue.
Les 3 raisons qui poussent un homme à abandonner une femme. Premier, à côtoyer de multiples choses. Oui, cette petite fille qui était l'époque, elle, avec sa grand-mère et sa grande soeur, le trône, se prennent dans les gens, ramasser chaîne des gens, ramasser habits des gens, pour les faire fétiche. Mais, bien sûr,
Okay, so basic router configurations, it's these things. So this is an example. Host name, the name of the router, router 1, enable secret, you add the password. Please, you must document your password. If not, you can forget. Write it down somewhere. Now to protect the user mode, line console 0, what, the telnet, to encrypt all your clear text password, service password encryption, and the banner message of the day. You exit and you save. Copy, run, start, or copy, running config, startup config. We'll be doing all the time this one. So please have a look again and we continue. Okay, so we'll get time to go through it via some labs. Yeah, you see, so we'll have some labs where we do all this stuff. We're going to play around a lot. Now, routers has some interfaces. How to configure an interface. I think last time we did a demo. You tap in the global config mode, you tap interface, the name of the interface, exactly the same name. If you tap another thing, it's something else. You can add a description like this interface is linked to router 2. It's not compulsory to use it, but it's good. Then you add the IPv4 address if you have it. It will be given to you in the question paper. If it asks you to add also IPv6, it will be given to you in the question paper. You add it and you tap no shutdown. It's like you are switching on the light, no shutdown. So this is an example of config we'll do. So check and we continue. So you'll get time also to practice with this. So this is an example of configuration. We are here on R1. So anytime you have a test or exam or lab, take 1 or 2 minutes to understand the topology. What is happening? Don't just jump and start. No, no. Here I have router 1, and on my left side, I have a LAN or a class. My router 1 is connected to router 2. Router 2 is connected to the internet and another class or a LAN. Try to understand the topology, then you can start doing your work, your tasks. So router 1 here, we are configuring an interface gig 000. You see this one. You can tap everything gigabit Ethernet or G, only in 000. When you're in, you can add a description. It's linked to LAN 1 to a LAN, you see. Now you add the IP addresses as given in the question paper, IPv4 and IPv6. Then you tap no shutdown and you exit. So when you exit, it's going to switch on, you see, trying to set to switch on the light or to power on that interface to become live, it will be ready to receive and send traffic. So check this one again. Okay, we'll get time to do some labs for that. And if you want to remember what we did last time, show IP interface brief. It will list all interfaces available on router 1, their IP addresses if you configured them, if you're up or down. And you did the configuration manually. Show IP interface brief, it will display IPv4 only. If you have IPv6, you tap show IPv6 interface brief, and it will display the same thing with IPv6 addresses. So check this, check also, and we continue. Okay, we continue. So here we have some comments and to verify some stuff. Show IP interface brief. Will display all interfaces with IP address and status. Show IP route to display the content of the routing table. Show interface. So we have new stuff and new friend. So check also, it's very important. So that when we start a lab, you know a bit already and it's easy to. Okay, we'll get time also to play around with that. Show IP interface brief, show IP interface brief, IPv6 interface brief also is there. Show IP route, it will display the content of the routing table. Show IP route for IPv4, show IPv6 route, it will display IPv6 stuff. Then show interfaces, gig 000, everything's up, and all a lot of info here. Show IP interface. So you can say show interface, show interface, the name of interface, or show IP interface, the name of interface, it depends on what you're looking for. And the default gateway, I did explain to you last time. If we are in a class, our door to go out and in is called the default gateway. From that door, we can change rooms from our class to the outside. So the default gateway is the IP address of a router that will allow packet from a network to go to another network. We did that already. So if you take R1, PC1 and PC2, they are connected via G000. So G000 will be the gateway. If you want to go to another network, they need to go via that door, that gate, before going elsewhere. So the default gateway is used when a host sends a packet to a device on another network. So check this, you can continue. Okay, we did that a bit. So something we'll do also in some labs, default gateway on a switch. This is how we configure IP default gateway. So if you want to explain, if you have a switch and you want also the switch to get the default gateway, and you tap IP default gateway and the IP address of the router. So a switch must have a default gateway address to remotely manage the switch from another network. From time to time, we'll do that, but it's not. We have a lot of packet tracer for us to play around. Display router information, configuring interfaces, view configs. In packet tracer to troubleshoot some issues. So that's all for this chapter. We have some videos around. A lot of labs we'll be doing step by step. But please, by your side also, study, play around with some labs. If you have questions, Saturdays, feel free to ask. Make a list of what you don't understand. Every Saturday, you're free to ask. Or you can also paste in the WhatsApp group and we'll help you. Okay, you can check that summary and we continue. And we finish. Okay, guys, I think it's quite clear, and we'll do some labs to practice. We also have some videos in NetAcad that you can check. If you have questions, please feel free to ask. In 2 minutes, we're going to end this session. Okay, we are done for today. At least we know about the router. We know about the router now. What we need to do is to practice a lot, to do a lot of labs. So if no questions, then thank you for today, and we meet again on Saturday, CPUT, 9:30.
Okay, thank you so much, sir.
Thank you. Goodbye.
Bye.